Hey, Sona, could you please let our co-founder, Bing? Yes.
We're live, everybody.
Hello.
Welcome.
Hello, everybody. And Josh, I don't see anyone in the waiting room, but once he's in, we will accept him.
Okay.
Awesome. All right, welcome to the Baseline Show this week. We are streaming a little earlier than usual. So we'll see how this time works out for some of our viewers as well as our live studio. We are here with the zkPass today for part 2 of a live stream. We had them on a couple weeks ago. Feel free to check out that stream afterwards, but we're here for part 2 to learn more about what they're doing, the use cases, the actual projects, and we will find synergies with what we're doing in the baseline world. So Annie, I think I can start by handing off to you.
Yeah, sure. Thanks, Sona. And thanks for inviting us to the second part of the Baseline Show. I was very happy to introduce you guys to what briefly, like zkPass we're trying to build here. And I might just quickly cast a slide on our use cases and elaborate a bit more from there. Okay, let me know if you guys can see it.
Still loading.
Still loading. That was a bit slow. No, still no.
Still no.
Not yet.
You know what? I'll probably just talking. It's not that complicated. It's basically a slide that shows. Obviously, we have pretty broad kind of like scenarios where we have many use cases, starting from the pretty straightforward ZK KYC compliance onboarding. For example, zkPass we here can enable users to prove that people meet some sort of like regulatory related requirement, such as your age being over 18 or 21 years old, or your nationality, whatever it is, without disclosing much of the exact detailed information, such as your date of birth, your whether if I want to prove that I'm not American, without letting them know exactly what nationality I am, I will be able to do that. So using zkPass, users can essentially generate zero knowledge proof that can confirm that they meet the certain whatever age criteria, providing a more privacy preserving solution for some of the age restricted services or products, such as GameFi project with a bit of violent content in it. And also zkPass can also be integrated into websites and online services that require age verification to ensure that users do actually meet the required threshold. And there's other things like online gaming identity verification, social media platform authentication. We essentially can be integrated into social media platform to verify user identities, reducing the risk of fake accounts and improving platform security. A lot of other use cases include in the DeFi kind of scenario, we can achieve proof of funds. zkPass can be also integrate into DeFi platforms to provide users with secure, privacy-preserving identity verification, as well as enabling seamless onboarding, reduce the risk of fraud. And for lending platforms, we can also be deployed by money market or lending platform to verify borrowers, not just identities, but also credit worthiness. And also, even if they want to verify their real world asset, on-chain asset, whatever it is, right? We can provide a pretty secure zero knowledge way of doing that. If you, like I mentioned last time, I believe in my slides, if I want to prove, for example, I have over 300,000 or whatever it is in my bank account to be able to achieve like a good lending rate, I can be able to do that without disclosing exactly how much I have in my bank account. And when it comes to governance and voting, we can do anonymous voting, participation qualification. Essentially, that can be achieved through kind of zero knowledge proof technology as well, right? So we can allow users to prove their eligibility without revealing their identity. And using zkPass, voters can generate zero knowledge proofs that can confirm that they are registered and eligible to vote while maintaining anonymous. And many other things for more secure, privacy sensitive information, such as even one's health records, whether we can also be adopted to enable secure and privacy preserving access to patients' possibly electronic health records, ensuring data integrity and patients' privacy. And stuff like clinical trial, we can also possibly be deployed to do like screening and applications and registry and etc. Educational background research, like if you want to verify whether someone indeed graduated from a certain faculty, university, you will be able to do that instead of them just putting it on LinkedIn, because there could be fake profiles and just fake claims. So all of that can be verified, because essentially you would have a login to your graduated faculty or your alumni. So most likely you will have that. You will have a transcript. You will have a graduation certificate. And an extension to that is kind of your experience checks, which you will be able to do that, your employment history check, and etc. And I think I'm going on a lot, and that's just a few examples of the use cases that we can be applied to. And let me know if you guys have any questions on top of that.
Mark Haddle, you looked like you're ready to ask a question. Do you have one?
You always say that. Do I always really? I mean, I'd be a lousy poker player. I mean, having too many tells and stuff like that. No, I think this is really interesting under the zk knowledge type of applications. Is really when you start to where you have a need to where you need to gather data. Say you're in a university setting and you need to query I don't know, financial data on a certain population demographic within a certain region, and you want to find out, okay, I need to find out of these people, how many are there, of course, how many are male and female and so forth, but also how many are homeowners, how many have no credit card debt, how many have higher credit card debt. I mean, all of these are really sensitive things that you could not ask directly, but you could in a range proof type setting come in and say, I need to at least identify, say I'm doing a study, I need to identify people for the population that I'm going to be drawing my data from. And how do I find these people? And so you could do a query like this, with the data saying, hey, I have a permissive purpose, but I am not violating any privacy. I am not getting any identification of any individual on there, but I am getting actionable data that these people meet the criteria of what I need to conduct my research on. And so have you ever considered something similar like that, to where
that is definitely very true and valid. That's what we hopefully can achieve one day, which is very, very high level of user profiling, without obviously revealing their identity. But this does require, firstly, a big accumulation of user base, because for any research like that, it's it's minimum thousands, right, if not tens of thousands, kind of like population set. So yeah, hopefully in the future, if everyone's kind of used to being able to prove like attestations using the zero knowledge kind of technology and be comfortable with it, and essentially just everyone have a bunch of SBTs and attestations to state that they are this, they graduated from here, they have this, etc. So yeah, hopefully that will be very valuable for sure.
Because I would talk to a lot of data scientists. Yeah, I would talk to a lot of data scientists, because that would be a really strong tool for their toolbox, is to be able to say, I can query these large data sets. And a lot of that's going to be population data, demographic data that is public domain and that is in, the government space.
Yeah.
And but you need the raw data, and they're not going to give you the raw data because, again, privacy.
Privacy.
Saying, hey, I just need to know these people. It's almost like, I'm a fisherman. Tell me which side of the lake that I need to go fish.
Yeah. Well, I can't even start with, like how valuable that will be. But yeah, like definitely it will be a long way to go, because that sounds like, like everyone, a lot of people needs to get on it, and for us to have like that kind of, base population pool first. Yeah.
Yeah. I'm thinking if you're doing, like trying to match user data and stuff, generally users, you're going to already have them vetted and onboarded onto your platform. So as users, these would be people that you don't know that you want to try to entice to maybe become users. So marketing would absolutely.
Yeah, no, what we're thinking in terms of go-to-market or marketing in general is obviously you would have, like the projects or business side, or however you call them, or we can refer them to business user for now, who have verification needs, who will come to us. They can be ideal IO platforms, or they can be a GameFi project. We actually do realize there are a lot of projects who have verification needs to prove that their users, their signups are not from a certain jurisdiction, which is kind of like the most common need. And obviously with that, you can obviously, like you can accumulate a lot of initial user bases through, their signups, their users, their potential users. And on the other hand, we will encourage, individual users who would like to essentially just mint like SBTs about their qualifications, about their, their experience, about their DAO membership, about their, if I own a Porsche, I want to tell people, I want to flash it. I want to tell people I have a Ferrari, just like how I want to flash my $20,000 NFT profile picture. Similar thing, right? So kind of that's what we're thinking. Like both sides, we can, start facing and try to entice, get people to sign up and, try it out. Yeah.
I mean, it gives you the capability to do a lot of things that you cannot do now just because of governance and privacy.
Yeah, no, definitely. And, it's essentially, in a more broader sense, anything web page based, as long as you have a login to it, we can essentially turn that into an online attestation. And, it's very valid. It's not tempered. It's true. Yeah.
Yeah. And I think just really with the advancement and proliferation of a lot of the ChatGPT and the generative AI type use cases, because now they're starting to say, hey, this is really cool, but wait a minute, the fuel for ingest in this, do we have it properly sourced, and was it legally obtained? And yes, we're scrubbing web data, but what is it? And so you're starting to get a lot of regulators looking at this, and a lot of people are saying, well, I don't want regulators with their flashlights, and guns and badges walking, poking around. So this is a way that you can at least have that arm's length thing to say, hey, I'm within the guardrails here.
Yeah, no, definitely. I think even when it comes to like Web2 world, there's like a lot of potential application there, right? Like, because remain anonymous, or like that layer of like privacy shielding is quite important to a lot of service providers. So we'll see.
Cool.
Thank you, Mark.
So I wanted to ask, I'm not sure if you showed this last time, but did you guys show what using zkPass actually looks like for a user, whether it's like a business who's trying to provide KYC for customers, or a customer who's like engaged, like getting a bank account and they need to provide KYC? Did you show what that looks like, or could you?
I think we could show a demo of, when you are trying to mint a SBT to prove your, let's say, account, internet bank account balance. which is, we have a few scenarios. One of them is like proving your legal identity, you're Australian, which you can do that by logging into your MyGov Australia, which is like the government official website, to prove everything about yourself, your essentially legal information, all your digital IDs there. And I think it's worth showing that demo, which Ryan, if you can pull it up, I think my casting is a bit off. And that one is essentially proving that, it can be, in our case, is only proving you have over $30, but you get the idea. It can be 300,000. It's only $30 because that was almost obsolete internet bank account. But yeah, we'll play that for you.
And on that note, can anyone plug zkPass into their own applications and use cases, or is it more so on the user side?
Can you guys see my screen here?
Yes, we can.
Yeah.
Okay, let's get started. Okay, once you log into the homepage of the zkPass, there will be a zkSBT. You click Mint zkSBT. And we have already classified as the server type into seven types: on-chain, legal identity, financial, social, education, experience, and skills. Because right now I want to approve that I am an Australian. So right now we have to choose the verified data source. It's the official government website. It's called MyGov. MyGov is a digital identity of all the Australians. So I want to verify I am coming from Australia and I'm an Australian. You click Meet now. And now it is under processing the multi-party computation and TLS sections. So roughly it takes 10 to 15 seconds. Once it's done, it's now the zkP process. So the zkP will be generated on, locally, and you have to submit it on chain, and you can verify on chain. Once it's done, you can see all the information about your zkSBT on your profile. It shows the data source you are generated from and the website, your verified field. All of the information. And you can find your zkSBT on-chain in the Explorer. Just click the hash here and you can find on-chain. That's it.
Thanks,
Okay.
Ryan. He
Yes.
actually played one that's proving your nationality, but you get the idea. It's similar concept when you're trying to prove your internet bank balance is over a certain limit or between a certain limit or however it is. You can, pretty much define what you want to verify, like in terms of the criteria. And essentially, yeah, like because of the fact that we know these credentials were generated from a trustworthy data source. For example, in this case, it's mygov.gov.au, which we know obviously that's the government website which hosts every Australian's digital ID. So yeah, through that, essentially you can prove I am Australian or I am not American with this way without disclosing way too much info of, instead of me sending you a copy of my passport bio page.
I have a question, if you don't mind.
Yeah, of course, Keith.
Yeah, so in a lot of the the research I've done and the kind of the ZK presentations I've been to, one of the problems or the underlying problems is the what's being used to produce the ZK circuit, all these domain specific languages, and the possibility of introducing errors within that circuit is generally much higher than logic, kind of this pragmatic logic that we've been using in other languages for a long time. So to someone who's asking, like, what's the guarantee that while you're constructing that ZK SBT, that the circuit that you're using under the hood, whether it be for nationality or private medical data or bank data, what's the guarantee that there is no flaw in that circuit, and then in fact you are proving something slightly different than what you say you're proving, right? Because in the end, I just received kind of like a zero knowledge proof that anybody can verify, but they're trusting that the logic inside that circuit is true, because when I run the verification, it's just kind of verify and say, oh yeah, this proof when run through the circuit is good, right? So what kind of guarantees do I have there? What would you say to somebody kind of asking that type of question, or that's especially like non-technical, right? And they want to use your system. Like, what guarantees do we have that you are verifying exactly what you say you're verifying?
Right. Are you saying, like, for example, the one that we showed you, how do you believe that it was actually credential was generated from that data source, essentially?
It could be that, or it could also be, let's say, what you're doing the money thing with the bank accounts. That let's say I missed a portion of the last presentation of Under the Hood, the debate with Andreas under the hood. But let's say, just to simplify the argument of, like, if we want to prove you have more than $3,000 or $30, and the circuit that's being used though is written incorrectly and has a flaw in it, right? And there's like a greater than rather than a less than, just for like simplicity's sake of argument, like, but I can't see inside that circuit, right? That's a black box. I'm just verifying against the circuit, right? So what guarantee do I have, that is correct, right?
I think it's kind of similar to last time. I think our tech team, Bing and them and Josh, we kind of it probably better if we can illustrate with that technical process flowchart. But maybe quickly, if either Josh and Bing can bring that up again, and essentially, just to, obviously, all of them will be open source, so that will be audited. So which, for those of you who are more technical background, to have a peace of mind, it's, more than welcome to. And I think Josh and
okay.
Yeah.
Okay, so I can walk you guys through the text side. Hold on, let me open my slides. Yeah, so basically what we are showing here is, okay, how user is able to kind of like get the data from whatever their Web 2 or Web 3 data set, like a data source. Let's say the legal side, you go for those, ANZ Bank, like my Gov ID and the bank account, those credits, you go for those bank website. That's basically what we do. So any data you are related to identity from Web 2 or Web 3 website, okay, we are able to use the zkPass protocol, convert that one into a zk SBT. And this is conditional.
Did you say you were gonna share the slide, right? I don't really see anything right now.
Yeah, hold on. Okay, so
I'm still looking for it. Sorry. Go ahead. Yeah. Oh, okay. There we go.
Okay, so can you see my slides now?
Yeah, I can see it.
Yeah. Okay, so before the slides, I'd like to walk you guys through this one. This one is kind of a more concise, like a procedures to like how basically it works. So let's just assume, okay, in this user flow, okay, maybe let's say compound is a launching activity, right? Okay, so they want to, over this activity, they want to verify, okay, number one, the user's real name, and number two, they're kind of like a Web2 bank account or something deposits. Then they just want to verify this is a real user. And the data source they want to use is Bank of America, BOA, okay? So the first step would be, so compound put the, the verified field, let's say the name and the bank balance there in the template and point to a data source. And then user side, Alice, she wants to join this event. So, okay, she going to pick this template from the compound side. And then the protocol is able to redirect Alice log into Bank of America website. So use her password and the username. That'll be the first step. The second step would be, based on the TLS level, okay, the Bank of America has a response back to, the protocol on the local Alice side, okay, with the name, account balance, right? That's would be the second step. And upon this point, okay, Alice would have two choices. Number one, Alice has a potential to forge the data. I say, okay, my bank balance would be only $10, but I want to change it. I want to 100 or 10K or something like that. So she has a potential to do that. So which means we do need a mechanism or system to prevent Alice from forging the data. So that's how we design this, the next step, which is the MPC, multi-party computation. And then we engage a multi-party computation node, which is the zkPass node here, V. Okay, the function of this node is to, number one, prevent Alice from forging the data. So how does it work? Is, okay, we have engaged the two keys in this process. Number one would be the, the encrypt key. So this key is to encrypt whatever, the responses from the Bank of America, which is, the name and the account balance, just to prevent the nodes from, accessing, Alice's private information. So only Alice in this case has the encrypted key. The nodes do not have it. That's the first key. Second key is the market key. So this key is the data integrity key. Okay, so the Alice side and the node side, they have a share, both has a share of the keys. So eventually, okay, once we finish the MPC, we need to check this key. If the key is verified, which means Alice do not forge the data. If we cannot, verify the key, which means Alice already forged the data. So that's the case. So that's the function of the MPC. Okay, so we run the MPC. Once the MPC is finished, you see the demo in the demo. Okay, we do have this MPC, right? And after MPC, okay, so which means, okay, we already get responses from the Bank of America, and we already prove Alice do not forge the data. Then, okay, we based off this responses, we generate this zkP, zero knowledge proof, and then we transfer this. We generate this zkSBT on chain and pass over this zkSBT to Compound. So Compound is able to verify, okay, Alice as a user, we approved username and account balance, and the Compound do not, have exact information of the Alice due to the, zero knowledge proof. So that's basically the whole flow. If we go one step further in terms of like the more detailed technical side would be like this. So the first one would be, okay, so Alice as a user P, right, is the user side also. So they just do the, client hello. So just use the traditional TLS level. So just send the access token, have the, client hello handshake to the website. And then, so website do have like a certificate, pass over back to the Alice side. So based off this, certificate, okay, the user side and also the node is able to generate this, their kind of like a public key. So this is the public key, and then we combine, because we have this two-party TLS into three parties. So we combine this node and the users the key into a combined one, which is here, you see. And then so based off this combined keys, okay, we generate this pre-master secret, and we have this. So that's the pre-master secret we have based off this, the keys, the public keys from the MPC nodes and the user side. So what I'm describing here is just the typical like a TLS level, how the protocol get access from the Bank of America, and also how we are able to, the protocol helps, to get the data from, for the user and without the user to forge the data. So, and then once you get this pre-master secret, and then so each party generate their pre-master secret. And then eventually over this MPC, we check this, you see the step 7 is we check a mark. So in this mark, we check the market key and also the query from the user side. And the step 8 would be the request, you see. So this is the Q dot would be the encrypt. So encrypt, the function besides the encrypted key and also query. And then so step 9 would be the responses. And then we also do the encrypted side. And also we check this market key. And so with those combined the pre-master secret. So that's the step 9. And then up, so the step 10, 11, and 12, that will be, okay, once we kind of finish that one, okay, we need to check the, the market key and the encrypt key together as the whole MPC. So this, once the MPC is finished, and then we jump over to, to the zero knowledge proof. So for this zero knowledge proof, okay, we need to check the few constraints. So the first one would be, you see the first line is the encrypt key and the responses. So this is the public input. This is kind of more like a public input. So to verify that one. And then we verify this market key and to check the market. So then we need to, check this kind of like the asset, which is the query, which is the kind of like the responses or the queries we get from the user side, and also the query of the token, which is the questions, and the asset is more like responses from the the server side. And based off this all those verifications, and we generate the proof based off the above above 4 statement. And then that's basically how we generate the zkP. And you see for each kind of like a template, or for each like zkP, we have a different like constraints. You only need to change the constraints here. So that just changing like a double-take the circuits. And then so that's how you generate proof, and then just then transfer this proof online on chain, and then you're able to verify, use the zero knowledge smart contract to verify it on chain. So basically that's the whole process. Let me know if you have any questions on this.
Yeah, I think Josh went on pretty detailed in terms of the process, but just to add on a bit on the black box front. So it won't be a black box because, right now we're just going through like testing phase, but eventually, obviously, we will become open source. So it's, open to anyone's literally going through the codes. And for example, if it's a SHA-256 circuit, you can literally see pretty much every step of it. So, like you will be able to audit or go review it yourself. And essentially, for example, if let's say today we have a community programmer who's from, I don't know, let's say Brazil, and be like, hey, zkPass, we can actually help you add this new Brazilian bank to your data source, which you don't currently have. So we will be open to kind of like delegate that to community, which they can obviously help us adopt new data source, and it's literally a matter of like changing the template, and which then will be audited by the community, by our internal committee and the community, and external audit, and which then will be combined into the code. And obviously everything is open source and it's subject to pretty much everyone's audit. So if that makes sense.
Yeah, that makes sense, and that's awesome to hear. I do have some questions related to this flow, but since you touched on, open sourcing, Annie, is there any idea you can give us of a roadmap of kind of, when that would happen, when people can start getting involved? Is that already happening? When can I use the zkPass kit? Anything like that?
Yeah, so in terms of roadmap, we are right now kind of like doing our pre-alpha testnet. So we're a bit far from mainnet yet, but won't be that far. Likely gonna be Q3 for mainnet. So in terms of like open source will be after testnet, we believe. Yeah.
Yeah,
Okay,
so
and
pretty much we are going to kind of like do the auditing and be open source when the mainnet is out. So that's basically
Yeah.
Okay, and are you looking for individuals or entities to eventually be running zkPass nodes as well as part of the net, or?
Yeah, that's true. We do, as you see, we do have this MPC decentralized network helping the whole system to do the multi-party computation. We are going to have a community of like the node runnings, and could it be the individuals? Also, a lot of VCs, and they are kind of like very interested in running the nodes as well. Yeah, you are sure. So that's kind of like the direction we are going. Yeah.
Okay, so for people that may potentially be interested in running nodes, what is there? Is it just if they like the idea and want to participate in this type of system? What can they gain, right?
Yeah. So in terms of the benefit of running the nodes, and there are two type of benefits. Number one would be so running nodes belongs to the community like rewards. In the tokenomics, we do have a large portion of tokens allocated to those, the network. I think we have like a 5-year plan of those token allocation to those decentralized network runnings. That's would be number one. Number two would be for each verification, we are going to charge a certain fee for just kind of like this would be the income source for the protocol, and for each verification fee, we are going to allocate 50% to those nodes. And so that would be the benefit, and the investment that the customer need to do. They need to stake certain amount for tokens zkPass in order to run the nodes. That would be the number one. I think the initial design we have like a 10K of zkPass. Number two, they need to have so kind of like a AWS or Google Cloud type of like a computation power in order to run in the ecosystem. Yeah, so that's kind of like the how we design the whole the tokenomics.
Okay, all right. Well, since you brought up tokens, when will this token be available, and how can I get some?
That's okay. And we I think we are launching the tokens pretty much very close to the mainnet launch. Would it be the quarter near the end of the quarter 3 or maybe quarter 4? I think it should be around quarter 4 or something like that. Yes.
Okay, all right, thanks. Yeah, sorry, I had to ask once you mentioned tokens. I think you need to ask, when they're going to be out, right? Because
yeah, that's a
I
good
like
question,
what I see,
actually.
right? With zkPass, they could be hot, right?
Yes. Right. So basically, tokens is a very important like a part of the ecosystem because we need those tokens. So in order to run in the nodes, we need those tokens. Each individual, they need to stake certain amount of tokens. That's we have to have those tokens pretty much before the mainnet. Yeah.
Okay, cool, thanks. So now to get back to my question to this chart, I know last time Andreas put you guys through the fire. I'm going to just assume for that part, I trust, the process of, the certifications and the keys. What I'm interested in, though, is kind of at what portion, probably the next slide, where the ZK circuit, the actual ZK proof is being created. At what portion in the flow or the user flow am I able to kind of create a flavor? Let's say if it is bank account, and everything's done correctly with certs and keys, but where can I, as a user, set, well, I want to prove greater than 3,000, right? Is this going to be like in the interface where I can alter kind of like from a set of pre-made circuits, or,
You're absolutely correct. So essentially you can, whatever it is that you want to verify, let it be over 300,000, 30,000, whatever, 50,000, you essentially key in that, which, they are like the, like various fields that, can be then obviously be coded into the circuit for the verification. So yeah, let it be greater than, smaller than, in between, or whatever, right? Essentially, there are a few scenarios for stuff like, numbers.
Okay. Can anybody speak to kind of how you're accomplishing that under the hood? What ZK language or DSL you're using? Is that being like generated on the fly? Can anybody give some insight as to that, or the route that you plan to take if it's not fully there?
Bin, do you want to kind of like mention a little bit overall kind of on the ZK side, how we design kind of like how which ZK we use and how it's been implemented?
Okay. So for the first version, we will use Plonk as our ZK algorithm, and so the most work here is to write the customer gate here and give a few optimize for the circuit. And so actually there are about 3 main parts. So the first one is the authentication of the response. So here there is actually just an SHA-256 circuit, which is a common in the Plonk, and we don't do we don't do much optimize for this part. So the second one is to pass the response to a specific grammar for the response, because actually all the pattern of the response is fixed when we do or we define the template. So we should pass if the response is actually what we have defined in the template. So this is the part. And for this part, actually, we don't need to do it in the circuit, because there's a lot of if-else case in the circuit. So if we put all this together, the circuit will be very, very large. So, but we can just pass it out of the circuit, because actually each input where or output, if we open the pattern or we open the grammar, the response, I mean the response format to the verifier. So the verifier can just know which where in the circuit is actually the data, or which where is actually the pattern or the key. So it could directly generate circuit or check if the check if the circuit is generated is right or not. So we could do this out of the circuit. So the second the part is the assert. We need to make sure that the assert response, some value in the response, for example, the age is actually larger than 18 or something else. So this part we have already released a few, code. For example, we will release some greater than or equal or in or some sum of or something like this logic. So I think almost the developer can just check our code and they can just rewrite a few part. I mean, change some part, and they can generate their own circuit. So this is how we will do for the proof.
Okay, all right, yeah, very cool. Thank you guys. That's most of my questions.
Thanks, Keith. Just obviously the technical part, they're the expert of it, and it's, if it's just worth highlighting that our speed of zk proof generation is currently sitting at around 16 seconds, which I believe is pretty much way ahead of other competitors. I think our team is still working on optimization to hopefully bring that further back down to around 10 seconds, which obviously will make us more commercially viable than a lot of the other competitors who might be taking over 1 minute. So yeah, just like to highlight that. And yeah.
Awesome. Any final questions from the group?
Great stuff.
Thank you.
Thanks,
Yeah, we
guys.
have been working on this for like a very long. We started zkPass like from last year Q1. So in zk, even before that, we kind of like did like pretty much like a half a year of like a zk related like a deeper research. That's so.
Actually, it would be cool to hear the story of how zkPass started and how the team came together. If you could end with sharing that with us.
Yeah. So yeah, Andy, do you want to? Yeah, you can say something. Go ahead.
You go ahead, Josh.
So pretty much, zk. So overall, Bin is the co-founder tech lead, and so his background is he has been working in kind of cryptographic space for like 15 plus years, and he was like a tech lead in NTT Docomo. It's more like a T-Mobile type of Japanese company, right? Or ATT type of T-Mobile, I would say, yeah. So he has been in that space for very, very long, and he has the first project he did related to like zk was like on the Mina protocol, but somehow he found there's some problems on that protocol. So basically he had some ideas about how we should do something, and then so my background is kind of like I'm a co-founder more like a strategy and a product side. I graduated from University of Missouri with a PhD in structural engineering, and I worked in New York City at GMS as a senior engineer from 2015 until 18. After end of like I think I quit my I think it was 2018 January. I quit my job, so I started my first kind of like blockchain projects, and then but somehow it didn't work out. So that was kind of like a tokenizing real estate. It's more like a real world assets. Now you see it's like a hot topic now, but it's kind of a little earlier, I think. So we kind of be and me met together at one of our colleagues in like a party. So we kind of like hit it off. Okay, so he had some ideas about like how the world is pushing forward in terms of like the zk, and also there's something we need to do on the identity side. And then I heard, okay, this is great project ideas, so maybe we should do something. So we kind of like talk about this zk. I mean, I would say pre-zk kind of like a period for about a half a year or something, and we have a few other like we have Bing has one classmate, and we kind of talking about zk and read papers. So we decided to we are able to do something in this space. So we officially launched zkPass. I think it's Q1 2000 last year. and then so we have we know Annie very well, and so she's in Australia, and she's from like a traditional like a banking side. Okay, she's very easy. She's very good kind of like outreaching to like investors and also the business development side. So we have so Annie and also Ryan, they are more on the the business development side. So that's how basically the initial like the core team of zkPass. And then we got into balance incubation, I think last year, and season 5. So out of season, for the season 5, they picked like I think the 12 teams out of maybe a thousand applicants. So zkPass is okay, 1 out of 12, and we are the one of the 2 teams. They categorize as infrastructure. So that's how we are not a DID project. We are not kind of like those very simple application those projects. So we kind of like the infrastructures. So that's kind of like how balance put a label to the project. And then after the 3 months of like incubation, okay, we had a demo day. So okay, 12 teams competing with each other. Okay, so zkPass we're number 1. I think Balance Labs kind of like are broadcasting this this kind of like a demo day, because that was the first one they ever did in the metaverse. You probably see, I think they already have like episode 1 coming out. Right. I think it's episode 1 is already out. So and then so we did it very well. So we are number 1 in this demo day, and then so that's how we in terms of like traction side and also the seed investment, I think we have very good track it. And so we haven't officially launched the the pre-alpha testnet, but we already have like 100K of like a register to try the testnet. That's number 1. Number 2, I think our Twitter accounts is something we get like 80K of tracks. This is all kind of like organic, and the balance side, of course, they helped with the traction side as well. And so what else? Seed round investment, I think we have very good investment like investor list. So that's kind of like so.
That's good. I don't have too much to add, and thank you guys so much for just doing this with us for a second time. And any other questions can always let me know, whether in the group chat, offline, etc.
Yeah, sounds great.
Sorry,
Go
just
ahead,
one last thing. So yeah, how do I stay up to date on zkPass? It seems like you guys have a lot of great things. But to me as a developer and somebody looking forward to this open source stuff, I'm just kind of like, waiting for these things to come out. So how do I stay up to date? How do I know exactly when the token's coming out, when you're open source? Like, how do I,
Appreciate it, Keith. And definitely follow us on Twitter, and obviously, put down your address for the pre-alpha testnet, and we'll keep you posted.
Awesome. Sounds great. So look for zkPass on Twitter, LinkedIn, and the social channels. And we will stay in touch on when things are open source and follow along with your guys' work closely. Thanks for joining us again. And anytime you want to hop back on, let us know and we'll slot you in.
Thank
Have a
you.
good-
Thank you. Thank you guys.
Have a good week,
Thank you.
everyone.
Thank you.
Thank you.
Okay.